Good morning students, and welcome back to the next video lesson from the chapter Work, Energy and Power. Today we shall be discussing about another form of mechanical energy, that is potential energy, followed by a discussion on energy transformations. What is potential energy? For this you may take the examples of the diagrams shown on the screen. In the first case, you can see a spring on which force is being applied from both the directions. What effect it is going to possibly produce? Obviously, it is going to bring about, or rather tend to bring about, a change in the configuration of the spring. Similarly, in the second case, if an object of mass m is falling from position A to position B through a distance h, then there is a change in the position of the object. This change in position of the object will also help in storing a certain amount of energy in the body, or rather utilizing a certain amount of stored energy in the body. So in both the cases, whether the energy is acquired by virtue of change in position or by virtue of change in configuration, this form of energy is called potential energy. So we can define potential energy as energy possessed by a body by virtue of its position, which could be height, or configuration, which could be shape or size, is called potential energy. Energy possessed by a body by virtue of its position, which could be height above the ground, or configuration, which could be shape or size, is called potential energy. Types of potential energy. There are two types of potential energy: gravitational potential energy and elastic potential energy. What is gravitational potential energy? You can see the diagram given alongside. This shows a change in the position. So the potential energy of a body by virtue of its height above ground. The potential energy of a body by virtue of its height above ground level is called gravitational potential energy. For example, the energy stored in a body held at a certain height from the ground is gravitational potential energy. Energy present in the water stored in the reservoir of a dam is gravitational potential energy. Energy present in the satellites orbiting around the planet Earth is gravitational potential energy. Similarly, what is elastic potential energy? The potential energy of a body by virtue of its configuration or shape is called elastic potential energy. For example, the potential energy stored in a coiled spring of a clock is elastic potential energy. A compressed or stretched spring possesses elastic potential energy by virtue of its configuration. Now, let us derive a formula for potential energy. Now, the potential energy at a certain height above the ground should be equal to the amount of work done on the body in lifting it to that height against gravity. So let us consider a body of mass m, as you can see in the picture. Body of mass m lifted to a height h against gravity. Then work done on the body against gravity is given by force into displacement. Now, when a body is lifted against gravity, the force applied on the body should be equal to its weight. So, we can say force is equal to mg. And what about displacement? Displacement is obviously the height to which it has been lifted. So, work done should be equal to mg into h. The work done on the body in lifting it against gravity gets stored in the body as potential energy. So we can write down potential energy, abbreviated as P dot E, to be equal to mgh. So this is the formula for potential energy of a body due to position. The SI unit of potential energy is joule. Both work and energy have the same units. Now at this point I would like to give an answer to a question: can a body possess both the kinetic and potential energies at the same time? Certain bodies may possess both kinetic energy and potential energy at the same time. Some examples, like for instance a man climbing a hill, a bird flying in the sky, a flying aeroplane, and a body rolling down a hill. Transformation of energy. Various forms of energy are interconvertible. This means we can change one form of energy to another. Now, energy is available in several forms. We get energy from the chemical energy of food. Cars run on the chemical energy of petrol and diesel. Flying birds and moving people have energy by virtue of their motion, called kinetic energy. A stretched bow and the stretched elastic in a catapult both have stored energy called potential energy. Then you have different forms of energy like electrical and nuclear energy, light energy that helps us to see different things around us. So these various forms of energy can be converted from one form to another, and this change of one form of energy into another is known as the transformation of energy. So as you can see right now on the screen, there are some common energy transformations taking place, for the purpose of which we are making use of many appliances or machines. These are the energy converters, which convert one form of energy into one or different types of energy. Like for example, you can see electric lamp that converts electric energy to heat energy and light energy. Electric iron, where electrical energy is getting converted to heat energy. Radio or in a transistor, electrical energy is getting converted to sound energy. In a dry cell, chemical energy is getting converted to electrical energy, and so on. These are some common examples of transformation of energy. Now, let me show you this picture. If I ask one question, what kind of energy transformation takes place when a body falls from a certain height? For this, you may refer to the first picture. When a body falls from a certain height, it loses potential energy and gains kinetic energy. Thus, when a body falls from a certain height, its potential energy changes into kinetic energy. Again, what kind of energy transformation takes place when a body is thrown up? When a body is thrown up, its velocity gradually decreases as it goes up due to the downward pull of the earth. As a result, its kinetic energy decreases and its potential energy increases gradually as the body goes up. This continues until a certain height. The kinetic energy of the body becomes zero. At this point, the body has maximum potential energy. So, when a body is thrown up, its kinetic energy decreases and the potential energy increases. So, we can say that when a body is thrown up, its kinetic energy gradually changes into potential energy. Similarly, take the example of a simple pendulum. A small metallic ball called bob, suspended by a light string or a thread from a frictionless rigid support, is called a simple pendulum. A simple pendulum has been shown in the picture. So the bob of a simple pendulum swings from one extreme position to the other through its mean position. The bob is at its highest position at the extreme positions and lowest at its mean position. The energy changes which occur during the motion of the bob, you can see it very clearly in the picture. So when a pendulum swings to and fro, its energy is constantly changing in a certain sequence. So you can see in the picture that at extreme right position there is all potential energy and no kinetic energy. Coming to the mean position, no potential energy, all kinetic energy. Then to the extreme left position, all potential energy, no kinetic energy. Back to the mean position, no potential energy, all kinetic energy. Again to the extreme right position, all potential energy, no kinetic energy. In this manner, the swinging pendulum keeps on continuing until it comes to rest due to friction at the support or air resistance. I will give one more example to show in what way the solar energy gets transformed into other forms of energy. Transformation of solar energy into various forms is the most interesting and important phenomenon on the earth. The sun radiates heat and light energies by virtue of nuclear fusion in its interior and on its surface. So the energy coming from the sun gets transformed into various useful ways, as you can see in the figure. Kinetic energy of the wind. From solar energy you get heat energy, and eventually it results in the formation of wind. From wind it is used for generating electricity or doing mechanical work with the help of windmill. Heat energy is being utilized for evaporation of sea or ocean water. You get that results in the formation of clouds. Then you get rain or snow. So in this manner the chain continues. From solar energy you are getting light energy that is utilized by plants for photosynthesis, that gets stored in the body when food is prepared, so it is in the form of chemical energy. From plants we are getting petroleum, natural gas, coal, chemical energy which is stored in the bodies of animals and plants, that results in the formation of fossil fuels over a period of millions of years. Eventually these fuels are being utilized for generation of heat energy that is used in domestic and industrial purposes. The food that is stored in the body of plants, that is consumed by human beings and animals, which results in muscular energy in humans and animals that is used for doing mechanical work. So you can find that solar energy is the ultimate form of energy, and very rightly said that its transformation into various forms is the most interesting and important phenomenon on the earth. That will be all for today's lesson. Thank you.